Hello students, today we'll be discussing about the JEE mains paper that was conducted in 2017. So here onwards we'll be discussing all the 30 questions one by one, the concepts and the tricks to solve the questions of JEE 2017 mains physics paper. Okay. Question number 29. Which of the following statement is false? So you have to find the false statement, not the true statement. Wheatstone bridge is the most sensitive when all the four resistances are of the same order of magnitude. That is correct answer. This is correct statement. So this is not the answer, because in case of a Wheatstone bridge network of four resistors, this is a galvanometer, and here we connect a cell like this. This is a Wheatstone bridge network. In Wheatstone bridge, the most sensitivity, this bridge becomes most sensitive when all the four resistances are of same magnitude. That means this R, 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 if all are of same magnitude, then it is most sensitive. This is correct statement. Okay. Next, this is one. Next, what is second part of the question? Second option is in a balanced Wheatstone bridge, if the cell and the galvanometer are exchanged, the null point is disturbed. That means the galvanometer is this and the cell is this. If they are exchanged, that means in this, here I will put the galvanometer and here I will put the cell. By doing so, this will look like this. The cell is here. Now the cell is within the diagonal, and here I connect the galvanometer. By exchanging the positions of, if the cell and the galvanometer are exchanged, the null point is disturbed. The question is whether the null point is disturbed or not disturbed. This is suppose R1, suppose this is R2, this is R3, and this is R4. Balance means R1 by R2. So you can see that there is nothing going to change in the balancing point, because you can see here that this is one diagonal, this is another diagonal. This is one diagonal, this is another diagonal. So whichever diagonal you connect, the balancing point will remain the same, because in this case, suppose this is R1, this is R2, this is R3, this is R4, just like that. Here both are same, only the thing is that exchange. But here if it is balanced, then what is the balancing conditions? Here R1 upon R2 will be equal to R3 upon R4. This is the case here. Here what will happen, if this is the EMF and this is the galvanometer here, then this by this by this, that means R3 over R1 must be equal to R2 over R2, R4 over R2, this by this. Now if you see it properly, then you can exchange this. If you, because this is one equation, I can write this as R3, this is brought down to this side, this becomes R4, this goes to the other side, this is R1 divided by R2 as it is. So you see here, this R1 by R2 is R3 by R4, here also R1 by R2 is R3 by R4. So this is also not going to change. So this may not be the answer, because we have to choose the false statement. This statement is correct. By disturbing, it is not going to change. Okay, null point is not change. Extend the null point is disturbed. So this is the question. This is the answer actually, because in a balanced Wheatstone bridge, if the cell and the galvanometer are exchanged, then the null point is disturbed. But what we are getting is null point is not disturbed. So this is a false statement. This is the answer to this question. Let us check the other two also. He says that a rheostat can be used as a potential divider. Let us see whether it is possible or not. This is a rheostat. Rheostat is basically you have a number of solenoid type of object where you have got number of coils connected close to each other. You can change the resistance by tapping somewhere from here. You will have different resistance and trapping here, you can slide that and get different value of resistances. So it divides basically the resistance of a given resistance into two different parts. So when you divide the resistance, you divide the potential also. The rheostat can use as a potential divider. The answer is okay, is correct, that it is also used as a potential divider. By dividing the resistance, you also divide the potential. So that cannot be the answer. So therefore, this is not the answer. Kirchhoff's second law represents energy conservation. This is a very simple thing, that second law is based on the principle of conservation of energy, that the total EMF and the potential drop across the each of the elements is zero. So that is true, that it is based on the principle of conservation of energy, and the first law is based on the principle of conservation of charge. So that is also correct. Next we move to the last part of this question.